Most students intuitively understand that addition produces a sum or total. The meaning of subtraction can be more difficult for students to comprehend. Difference refers to the meaning of subtraction in numeration. For example, if we have a group of 7 and a group of 9, we can find the difference between these two groups by removing one item from each group simultaneously until we are left with no items in the smaller group. The number of items remaining in the larger group is the difference. In this case, the difference between 7 and 9 is 2. We can model difference on two 10 frames. In the top 10 frame, there are 3 blue counters. In the bottom 10 frame, there are no counters. All of the counters in the top 10 frame are different from the bottom 10 frame. So the difference between 3 and 0 is 3. Now we have 4 blue counters in the top 10 frame and a red counter in the bottom 10 frame. In the first box, both 10 frames have a counter, so that's the same. The top 10 frame has counters in the next 3 boxes, but the bottom 10 frame does not, so that is different. The difference between 4 and 1 is 3. In this example, we have 5 counters in the top 10 frame and 2 counters in the bottom 10 frame. We can see that the first 2 boxes are the same. They have counters in both 10 frames. But the next 3 boxes in the top 10 frame have counters, whereas those boxes in the bottom 10 frame do not have counters, so that is different. Let's remove the counters that are the same, and we can see that the difference between 5 and 2 is 3. By now, some students should begin to realize that the difference in all of these slides has been the same. This is because we have been adding one counter to both the top and bottom 10 frames. If we add or remove the same quantity from two groups, the difference will stay the same. This concept of constant difference will be very important later on. Distance refers to the meaning of subtraction in magnitude. Distance is the amount of space between 2 points, in this case 4 and 6 on the number line. We can find distance by finding the quantity that makes these two magnitudes equal. In this case, the distance between 4 and 6 is 2. Distance also makes it easy to see that addition and subtraction are inverse or opposite operations. We can clearly see that 4 plus 2 equals 6, and 6 minus 2 equals 4. We can help students develop their sense of distances within 10 by practicing with Cuisenaire rods on a number line. In this example, we can see that the distance between 2 and 7 is 5. The distance between 2 and 8 is 6. The distance between 3 and 7 is 4. One reason why it is essential for students to develop an understanding of difference and distance is because many types of word problems involve these concepts. In fact, there are relatively few types of word problems that involve simple addition. Comparison problems are perhaps the most straightforward application of difference and distance. Consider the difference unknown problem. Ahmad has 7 cookies and Michaela has 3 cookies. How many more cookies does Ahmad have than Michaela? This is simply asking us for the difference between 7 and 3. Or consider a comparison problem when the smaller quantity is unknown. Ahmad has 4 more cookies than Michaela. Ahmad has 9 cookies. How many cookies does Michaela have? Again, we can recognize that we are being asked for the difference between 4 and 9. When most people think of subtraction, they think of separation problems with the result unknown. For example, Ahmad had 8 cookies. He ate 4 cookies. How many cookies does Ahmad have now? This is the takeaway interpretation of subtraction. While there is nothing inherently wrong with this interpretation, it only begins to scratch the surface of the power of subtraction and the concepts of difference and distance. For example, consider a separation problem where the change is unknown. Ahmad had 5 cookies, but he ate some of them. Now he has 2 cookies. How many cookies did Ahmad eat? In this problem, what was taken away is precisely what we do not know. However, if we understand the concept of difference, we can readily see that we are simply being asked for the difference between 5 and 2. Sometimes the concept of difference is important even when we are using addition to find a solution. In separation problems where the initial quantity is unknown, for example, Ahmad had some cookies. He ate 4 cookies. Now he has 2 cookies. How many cookies did Ahmad have at the start? In order to solve this problem, we must add the 4 cookies that Ahmad ate and the 2 cookies he has remaining to know that he had 6 cookies at the start. However, we are unlikely to be able to frame this problem correctly if we do not understand the concept of difference. Even join problems more often involve subtraction than addition. For example, when the change is unknown, Michaela had 3 stickers. Her teacher gave her some more stickers. Now she has 5 stickers. How many stickers did Michaela's teacher give her? To find the answer, we would subtract the 3 stickers that Michaela had at the start from the 5 stickers she has now. Or consider when the initial quantity is unknown. Michaela had some stickers. Her teacher gave her 3 more stickers. Now she has 8 stickers. How many stickers did Michaela have at the start? To find this answer, we would subtract the 3 stickers her teacher gave her from the 8 stickers she has now. In both cases, we must understand the concept of difference in order to frame the word problem correctly. Finally, consider part-whole problems where a part is unknown. Michaela has 6 friends in her class. 2 of her friends are boys. How many of her friends are girls? Understanding the concept of difference helps us to realize that we must subtract to solve this problem. We can incorporate the language of these word problems into our instruction on difference and distance. For example, we can ask students, how many more blue counters are there than red counters? When we remove the 2 counters that are the same in both 10 frames, we can see that we are left with 5 blue counters. That means there are 5 more blue counters than red counters, and the difference between 7 and 2 is 5. Now we could ask students, if you had 7 cookies, but you ate some of them, and now you have 5 cookies left, how many cookies did you eat? If necessary, we could back up and show that the blue counters represent the 7 cookies that we had. We have seen that the difference between 7 and 2 is 5. So if we had 7 cookies and we're left with 5, we must have eaten 2. Or we could ask students, if you have 7 friends and 2 of them are boys, how many of them must be girls? We can also incorporate this language into our instruction on distance. For example, we could ask students, if Ahmad ran 5 miles and Michaela ran 8 miles, how many more miles did Michaela run than Ahmad? The distance between 5 and 8 is 3, so we know that Michaela ran 3 more miles than Ahmad. Or we could ask students, if the line for the water fountain is 5 meters long and the line for the bathroom is 8 meters long, how much longer is the line for the bathroom than the line for the water fountain? It can be tempting to rely excessively or even entirely on the takeaway interpretation of subtraction. However, students who acquire a deep understanding of the meaning of subtraction in numeration, or difference, and the meaning of subtraction in magnitude, or distance, will have a tremendous advantage in not only being able to subtract, but in being able to apply subtraction to solve a wide variety of problem types.